Okay, so I'm sorry if I'm a little bit too loud. Also, sorry if you hear background noise. My parents are trying to put the little ones to bed. Okay, so first things first, net ionic equations and ionic equations. I'm only going to work 3 of these problems out since they can take quite a while. Alright, so this is basically a way to split up, like, to split up some double replacement reactions into what it is accomplishing. So, like, for example, well, here I'll explain it in a moment. So we've got this equation. We got 2. Helps if I get out this. Okay, thank you. 2. There we go. NaCl. You want to finish my L? Well, aqueous. And that aqueous is important. I guess I'll just finish my L. I hate writing on a screen. Plus would. Looks like they already balanced this for me. This is also aqueous. Yields. Now I'm gonna try to zoom this out some. Don't know how to zoom out. Alright, well then I'm just gonna try and move this. Alright, yields. I thought there was a way I could zoom out. I think there's a way I can move the drawing out later. Alright, yields. PB. CL. Why is it doing that? That is not the shape that I made. Cl2, and this is a solid. So what we will most likely have to do on the test is we're most likely only going to be given here we go. We're most likely only going to be given these right here. That's most likely all we're going to be given. And we're going to have to find the products. So this one's pretty easy. You just swap the places. You just swap lead and sodium. There are others where they are single replacement, and you'll have to use your activity series. And I'll try to make one of those later on. But we'll also have to determine, using our solubility rules, whether something is aqueous or solid, a precipitant. And if what just happened, sorry if you guys saw that, don't know what that was. What happens if there is no precipitant, if everything is soluble, if everything, if everything reads soluble on your solubility sheet, then there's no reaction. But here we have a precipitant, so we aren't worrying about that. 2 NO 3. And this is aqueous. So now, for the next step, anything that is aqueous, just do this. Anything that aqueous, we're going to split apart. Did you say anything that aqueous? Anything that's aqueous is going to be split apart. So we're going to have 2 Na plus, I'm not going to worry about writing aqueous, plus 2Cl minus plus Pb plus 2 plus 2NO3 minus yields. Now our solid doesn't split up, so we're going to hold PbCl2 right there. And we're going to continue splitting up after that. 2Na plus 2NO3 minus. All right, so now wherever things are the same on either side, so for example, we have a 2Na plus, or we have an Na plus, we have an Na plus. We have an NO3, we have an NO3. That's where things are going to cancel. So we drop the things that are similar on both sides. And that, so what I just did before crossing this out, that's my ionic equation. Oopsies. So now what I'm making is my net ionic equation, and that's just what's left. So 2Cl minus plus lead 2 yields PbCl2 solid. So what I was saying earlier, basically, is that what this is doing is it's finding what the reaction's doing. So this right here is the whole reaction, right? But what's being accomplished in this reaction is making lead chloride. Lead chloride. Sorry, I kind of said chlorate there. So I want to emphasize that's chloride. So this is what's overall being produced in the reaction. That's what's dropping out. Now I'm going to do one with single replacement. Now bear with me because I'm going to have to sort of make this one up as I go. So basically, you're just going to predict your products, right? Which is just done by doing a little swappy thing here. You swap the cations or the metals or positives, whatever you want to call them. So you can see, like over here, we now have lead with chloride. And then you check and see if they're soluble, if your products are soluble. If one of your products is not soluble, then congratulations, you have a reaction. If they are both soluble, then you have no reaction.